We were able to come back here today. I'm not going to say too much. I'm Tom Duden. This is Mike Obst, and we brought our technical guy, Michael Smith, as well from the company, and we're here with a new projector today, so hopefully we won't have the technical issues like we had last week. So really appreciate you giving Mike your attention, and I know you're going to probably have some questions. We might overwhelm you a little bit with what we show you, but you'll get a taste of what's going on in the industry. So I think you'll really enjoy it. So, Mike, go ahead and take it away.
All right. Well, I'm Mike Obst. I'm with Design Data. Design Data is a software development company out of Lincoln. I'm their research and development manager. So I work with lots of other software companies to improve on current methods of communicating between softwares and basically interoperability, which is our topic today. I would like to have you guys walk away from this knowing a little bit more about hands-on interoperability, seeing it firsthand and why it's so important in the way construction is done today. So we're going to be demonstrating 5 or 6 different softwares and watching this information being created all the way to the point to one of the uses. A lot of the BIM information we're creating is used by facility managers, which is basically kind of the end use of all the information that we're putting into these models. So a few questions before I get started. It looks like I've seen a lot of people in the room so far use Revit. By a show of hands, how many people have used Revit? Is it
everybody?
Everybody, okay. Is it architecture first?
Yeah, Revit
and
architecture.
only?
Actually, Suite version we are using.
Okay.
Revit Suite, yeah.
So any use of the software from an MEP point of view yet? Yes?
Yeah, we use MEP as well.
Okay.
A little bit.
A little bit.
Yeah.
All right. Because I'll highlight some different things in here, specifically when it comes to joists, trying to get that MEP information through the webs, you know, your roof openings at the top, trying to get all that ductwork and cable trays through those. We'll talk a little bit about that. Another software we'll use, has anybody heard of Synchro? It's a 4D BIM management software. Okay, a couple to show of hands. What software, do they use a 4D software here where you apply a schedule to a model?
That's for construction major students.
Okay.
They're here right now as a civil, architecture engineering, and construction all together here right now. So
okay.
Some of them may use it, some of them may not use it. Last time I mentioned the B office. We are using those for scheduling, estimating, content data.
All right, we'll spend a little bit of time there and show you how a schedule is applied to some of these models that we'll be looking at today. Navisworks, show of hands, Navisworks. Pretty much everybody there too. Okay. And then SDS2, that's the software that Design Data writes, and we'll be showing a fair amount in that also. So interoperability is our topic, and I'm going to kind of be talking to a couple of you guys at the back of the head, but in order to get that hardware to work right, I had to sit over there. So basically, I'm sure you guys have heard of BIM. It's overused, in my opinion. It means something different to everybody. But basically, I wanted to define it for this group because what a lot of people don't understand, it's a process. A lot of people think it's a software. Well, software is certainly the most important element of it, but the actual use of the information is a process. It's created at one level, usually a software, usually a 3D model, and then passed on to other people to add value to that model and to be used to extract information. So there's 2 different types of softwares we're going to talk about today, actually 3. One is an authoring software like Revit. It's used to create a model. It's going to get passed to SDS2, which is a manufacturing solution. It's a manufacturing model. So it takes the design information from the authoring software and manufactures it. I'll show you how we can send it out to CNC robot machines out in the shop so it can get cut, drilled, and welded, and so on. So that's the manufacturing side. Then there's the viewing side where all the, like Navisworks, where it's all assembled, all the disciplines are put together, and information is check for collisions, clash detections. I've talked to a couple students earlier, and it sounds like some have had some hands-on with that already. So I'll take some of those topics a little bit deeper. I'll sit down here and kind of talk from the back. All right, so who uses this? Basically, anybody in the construction workflow, whether it's the architect, engineer, all the way down to subcontractors, joist manufacturers in particular, we're going to highlight. I will show you a workflow of interoperability with Nucor Volcraft right here in Norfolk. Other things here in Omaha, there's a couple of fire sprinkler installers and fabricators. They want to extract information from this model too, so that they can put all the piping together in their shop before it's sent to the job site. That significantly keeps that cost down, electrical and so on. So that's who benefits from it. Oops, missed one slide, that's all right. So why is interoperability important? Well, the software all has to work together. And I've been at Design Data for 15 years, and I've seen the day when software did not communicate well with each other. This 3D model did this. Oops, somebody must have a wireless mouse. Basically, one software model did something really well, and another software model did something really well. They added value to the project, but the models could never talk to each other. It was really not so good. Oh, that's interesting. You can see I'm not touching my mouse. Let's go to the next slide. But basically, that's why it's important. Is interoperability has to function between software, or otherwise the BIM process just doesn't work. A basic workflow, what this represents is all the green arrows. I wonder if it's time. It might be.
I think it was animated when you practice.
What's that?
Schedule was recorded when it's practiced, something like.
It could have been. Oh, I bet you're right.
Moving automatically based on your schedule.
Yep, you're right. But basically here, these green arrows, I wanted to show this because any green arrow is where information, interoperability has to exist today. This would be your most common contract workflow, project owner, architect, engineer, general contractor, and then information back and forth between them. That's very common today. There's also a design build company that could do the same amount of work, but if you see, it's basically all of these professions under the same hood. The number of arrows is slightly higher because they're not forced. I don't know how to make that stop. I only got a handful of slides.
Okay.
Just one checkbox.
It's on the timings. There you go.
All right. Thank you. So that was the design build. The integrated project delivery. The purpose of all these slides is to show that all of the professions share information using different softwares. This is more a matter of who they share them with. Okay? Again, basically showing that interoperability, the softwares have to talk to each other. So here, starting out when an owner wants to do a project, they have the money to do it. They've maybe got a couple of ideas and sketches in their head of what they want to give to the architect. But the purpose of this slide was they want BIM information. They've talked to other owners. They see the value in it, but sometimes, and even with the way the contracts are written, it's not really clear what their deliverable is. What does that mean? Do they want a 3D model when they're done? Do they want to use it for facilities management type thing? It's kind of hard to understand that today. It's not real clear. The legal is a little bit further behind than what the software is. And I think that's always been the case. So the note for this slide is the project wants BIM, but they're not really defining it too well. So the architect. I wanted to show you here a few softwares that the architect might use that creates the BIM information in the model. Some of them I've seen here on people's desktops. I've seen some of them being used. So there's a few of them there. At this level, SDS2 isn't in the equation yet. We don't write a architectural software. We start at structural engineering and go all the way to the end of the project cycle. All right. So when the engineer gets it, regardless of what discipline is, there's a lot of software out there. Obviously, Revit, being the MEP side of it, is one that adds a lot of value to that architectural model. And understand that this is still a design phase. Most of the information that is in the Revit platform is not intended for manufacturing purposes. So this is a design, because one of the outputs of Revit is to create those 2D drawings, right? The design documents or the design drawings. That's one of the outputs of Revit. In addition to that, a lot of the architects, engineers are sharing that model with other softwares. So that's where the first-time interoperability is really important. Okay. Let's go here. Once it's past the architect, engineer, and it gets sent out for bids, a general contractor might use this variety of software to get their job done. It's still going. It still advances on its own, but that's okay. One of them that we're going to use today, we're going to talk a little bit about Microsoft Project and its timeline. We're going to demonstrate Synchro and basically take the schedule and the model and put a time assembled model to that schedule. So you'll see something get assembled in time. Okay, so one of the subcontractors to the general contractor that I'll put a focus on is the steel detailer. We, Design Data, writes a software, SDS2, and most of our market are structural steel detailers. That's why I kind of put this slide in there. And this is some of the softwares that they might use. There's quite a list. I do have the entire list here at the end. But I listed these because, again, interoperability. If these softwares have to talk to each other and they don't interoperate, this process just doesn't work.
Can you tell them what detailer is? They may not know what the difference between drafter, modeler, and detailer.
Okay, good question. The question is, what is a steel detailer? The steel detailer is a profession basically usually subcontracted to the general contractor, and they will take the design drawings that you guys are making from your Revit model, specifically the structural drawings, and they will take the structural steel and they will create manufacturing drawings, fabrication drawings from that model using SDS2. The ideal situation is I don't want to get a set of 2D drawings and then start up SDS2 and re-input the model that you guys already built in Revit, right? I want to take the Revit import, I want to bring it into SDS2, and I want to create these drawings. It's a good question, and I will show you some of the drawings and what they do there. Once the drawings are created, it's just like the design drawings, but much more detailed. They call out every bolt, every weld, how long the weld is, what size the weld is, because just like the design requirements of RAM or Bentley or any of that other software, it has to be designed and approved by an engineer. So once those drawings are done, fabrication drawings, they're sent back to the architect engineer for approval. The architect engineer puts their stamp of approval, that fabrication can begin on the structural steel, and then it goes to the steel fabricator, which is the next profession. So the steel fabricator will take the drawings from the detailer, they'll put them in the shop, and they'll start building the pieces for those drawings. In addition to that, the steel fabricator will use CNC information, which is basically a file that tells machines in the shop how long to cut a beam, How many holes should it drill? Where does the cope go and what size is the cope? It's a very, very automated process. And we'll look at a little bit of that too. If you can advance to the next slide. The other profession here that you might not hear too frequently is also the steel erector. And we do sell quite a few stations of SDS2 to this because we have a SDS2 erector package, and we're going to look at putting a crane in the model, and we're going to determine how far the crane can reach and how heavy of a load can it pick up at that certain reach. That's the level of information that's getting added to these models anymore. And if that didn't interoperate, I couldn't pass that to Navisworks, to check did I put the crane in the proper location. Okay. Hit the next slide. There we go. I added this one here because basically this, as design data, it's not so much of an interoperability slide, it's more of a design data slide where this is probably the biggest area that SDS2 markets to. The engineer would be the structural engineer. The general contractor, certainly by being air traffic controller with all these other softwares. The steel erector, the steel fabricator, and the steel detailer. Basically anything inside that blue box we have highly automated, and it all uses the same model. Just like Revit, if you use Revit to do your architecture work, you can use that same Revit model to do your MEP or your structurals. So one model can be used by all those people, in addition to sharing with other softwares also. And we will demonstrate that. Next slide. All right, so here's a recap on the software. Basically, back up one. There you go. Yes, I don't know why it auto advances. This is basically all the software that we have showed that either has to communicate in some way or another. Most of them do because, Autodesk shares with Autodesk really well. SDS2 does a really good job at bringing in RAM and Bentley models, those types of things. So I just wanted to show you how many softwares are out there. And not all of them communicate with each other, but it's a goal for almost every one of them to make sure they do. Because if you don't, and that project is required to do some level of delivering BIM information back to the owner, your clients won't be able to use that software. So it's important to understand where most of these companies are headed from an R&D point of view of what's next. All right, next slide. This is an important one because in the last 4 or 5 years, there's a whole new job title that has popped up at almost every one of the professions, and that's a BIM manager. Basically, with all of the data that's being transferred between professions, a BIM manager is required almost anymore for someone who does a lot of BIM projects. And what that means is the models coming in, let's just use the general contractor. The models coming in from the architect engineer, maybe as a revision, have to be managed in a model, in addition to maybe models that are getting passed back from the structural steel detailer. So there's a lot of managing that has to go on to keep this information straight and accurate. And that's a new profession. And if I had to guess, that a lot of you will probably fall into this type of a position eventually. In a way, I would imagine that's, let me rephrase that, I would imagine that's something you guys are probably looking forward to, that type of a job. You're doing it every day right here. So, BIM manager, that's the new title that seems to every single profession has to have. Next slide. All right, get that one. I'm going to start doing a couple of presentations or demonstrations of the software. I'm going to use Revit. We're going to look at a few things. Since you guys are somewhat familiar with that already, I will just touch on it a little bit. I'll spend more time in SDS2 where you probably haven't seen before. Has anybody seen SDS2 before at all? Okay. I will take that model from SDS2, demonstrating interoperability. I'll take it to Synchro. We'll apply a schedule to it and some different times. We'll take some PDF drawings to Bluebeam. I'm kind of surprised I didn't see Bluebeam in here. Do you guys use a PDF viewer? Is there a software that you use for a PDF viewer?
Yeah, Adobe.
What is it called?
We use Adobe.
Adobe? Okay,
Yeah.
got it. Bluebeam is a very powerful, it's even more powerful than Adobe in my opinion, because it's really set up for the construction world. And I don't own it, I don't sell it in a way that use whatever you want, but I haven't seen a software be able to do for the construction world what Bluebeam can for PDFs. It's incredible. You can mark them up, you can even mark up, I'll show you a 3D image, an RFI, that we can send and view, and we can rotate a little portion of the model inside of the RFI. So a lot of the RFIs are electronic anymore. And then we'll finish off with this project in the workflow and view it in Navisworks. Obviously you guys know a little bit about that. I don't have a lot of disciplines where I can combine them together and show you how electrical and ductwork and structural steel clash, but I've heard that some of you already been exposed to this concept. I'll cover it, but I don't have a real good model that shows all that yet. So I'll start out with a Revit demonstration. Any questions so far? All right. There's a quiz on the end on the structural steel detailing side, the steel fabricator.
Yeah, they know that.
Okay, so this is a familiar environment, I'm sure, for you guys. You've seen several models on your screen. So what I have here is basically the structural steel side of it, which I will focus on mostly because SDS2 is a structural steel software. This is a structural steel model. You see some beams, columns, some steel joists. What I wanted to show you in this is Design Data does write a software that interoperates with Revit, and basically it does connections. Let me find a spot here. Here we go. Okay, so when you put a beam and a column in Revit, it doesn't look like that in yours, does it? Probably not. There's no connection at all. Design Data writes a plugin right here. It's called SDS2 Connect. It's a software, and basically takes this beam and takes its loads, matches it to the column, and applies the type of connection that the user wants, and designs that connection. So we're going to look at a little bit of this. If I edit this connection here, I want to just put it back to a standard connection at the time. So clip angles. Anybody know what a clip angle connection looks like? It's a little angle on both sides of the beam. It's a little bit technical, but basically this is a clip angle, and on the other side of this beam there's another clip angle that hold that beam up. Well, I just want a clip angle connection. This is a moment plate and a moment plate that the engineer had defined that there's a moment on this beam, there's a rotation. That's why those are there. I'm just going to make it a simple clip angle beam. There you go. See how the moment plates went away? Okay. What we're trying to do here is, at the time someone is putting the 2D drawings together in Revit, there's a lot of times where they want to define, I want this connection, this is the engineer, structural engineer, I want this connection at this location. And they have to put that on the design drawings or in the model. Well, we're giving them a tool to do that. So this is a clip angle connection. If I go back in there and edit that, I have a wide variety of connections. Clip angle, shear tab, bed plate, seated, splice. So you have different types. I'll stay with the clip angle. We'll put a bolted moment on it. Now, I've seen a software on the machines here, RAM. Does anybody use RAM? Is it not yet in this class? Nope. Okay. RAM is a software that basically helps the structural engineer define and calculate the loads that are being applied to the beams and columns. Revit can store that information. So on the topic of interoperability, RAM can analyze this structure and pass the loads back in to these beams and columns. Our plugin interoperates with the information that RAM wrote, and we will use their information as an input to our design. So when the beam and column is determined that this needs to be an 8-inch deep column and a 12-inch deep beam, that's RAM's work. Design Data's work is, if this beam is spanning 20 foot or 40 foot, there's a certain amount of weight on there. Maybe rotation, also moment. Well, we read that information in. You can't see that icon up here. We don't have the RAM logo yet, but basically I can read that RAM information in, and it populates this screen based off of what the engineer had defined for loads. So, I mean, that's interoperability at its best right there. Revit, RAM, and SDS2 all using the same database to design connections. And there's my connection. Now, I want to point out the difference between an authoring software and a manufacturing software. I'm sorry, design. This is still design. I cannot manufacture this beam from this model yet, because I can't extract CNC information out to the robots in the shop. So basically we'll take this model, pass it to SDS2, and we'll add that one extra layer of information that basically allows this connection to be manufactured. Okay. Any questions on that so far? All right, I'm going to go one step deeper. If I look at this connection, a lot of times the engineer, the structural engineer, needs to know exactly how that connection is being designed, the math behind the connection. I'm going to do a report here. This is basically a design calculation. All right? All of the math this is basically the answer sheet. Here's all of the connections that were performed, or the calculations that were performed. Here is their value, and we designed this connection off of a certain standard. This one, I think it's AISC 13th edition, but basically the page number or the reference of where the equation came from. So that's the answer sheet to the engineer on the values or the loads. Sometimes that's not good enough. Oops, I did that mistake. Sometimes they want a deeper level explanation of where that connection, or what that connection derived from. So we have what they call a extended calculation. So this is for one beam and column connection. Look at all the math. Remember this on our cover sheet, our answer sheet basically, calculation 2 and 211. Well, if I pull down and look at this, here's the math that was used to generate the answer for calculation number 2. And the design passed with an OK. So this is the longhand explanation to the engineer. This one's a little bit bigger. Calculation here, here's its reference, and all of the actual values plugged into the equation with the result at the bottom. This value does not exceed the design value, so it's okay. All right, so do you see how interoperability starts to become really important? If this didn't work, you're going to have to do this in another software, and you can't link this to the model. Now the model contains all this information for anybody to use. All right, any questions on those? Let's see here. Calculation I think you've probably seen enough in Revit as far as structural steel goes to where the next step is, after it's all designed, I'm going to take it to the next software, SDS2, and I'm going to add one more layer of information to it. Alright, so here we have a Revit export. And basically I click that, it creates a file, and that file then is brought into SDS2, and I can have this member, or this model, in SDS2. Probably the most common file type, this is a generic statement, but one of the most common file types between softwares is IFCs. Anybody dealt with IFCs yet? Have you guys shot IFCs between softwares yet? Yes? Okay. Alright. So I'm going to basically take an IFC out of Revit. I already loaded this up because both Revit and SDS2 takes a little bit of startup time to import them, so I already imported it. I will import it, I guess. So this is our main menu of SDS2. We have, I think, 13 or 14 various softwares, but this is the one that basically has all of the functionality in it. It's our detailing version. I will do quite a few demonstrations in here. I'm going to go into a modeling environment. And because interoperability works, I'm going to import that model that we created. Okay, that looks pretty familiar, right? Same model that we were looking at Navisworks. And again, this is where interoperability is important. I seen the day where the architect engineer passed 2D drawings off to the detailer, and they rebuilt this model. Do you know what a waste of time that is to the project owner to recreate a model that's already been done? Not to mention the variance that can happen. A wrong section size, a column is rotated incorrectly, a beam placed slightly different than what it should have been. This is a much smoother process when the two softwares can talk together. Okay, so now we're in an SDS2 model. I wanted to point out, same thing can happen with these connections. If I edit a beam, it's a little different looking window, but basically I can change my connections here in much the same way I did Revit. So if the architect engineer wants to make a revision to this connection, or if they didn't define it, I can define it in SDS2 now. I can get the same calculations I did from Revit and so on. Okay. Alright, there was a good question about what actually the structural steel detailer does. I'll take a minute and show you that. So this is the Revit model in SDS2, and you say, wow, why do I even need SDS2? It looks the same. Well, we're adding that manufacturing layer of information. So if I take a beam, for example, right here, and I want to create a drawing for it, I hit a button here that basically details it, and this is why customers purchase our software. We will take a 3D object and create a 2D drawing from it. All the dimensions and the bill of material are already done. So this is the result of our software. I can take this building and basically hit a button, detail members. See how I already detailed one? I can detail the entire building, and it'll probably take a minute or so, but I will have drawings for every single one of the members that I brought in from Revit. It's almost done here. So if you imagine that, if you did this by hand, I can almost guarantee you this is a week's worth of work. And if we go in here and take a look at some of these, if I look at this brace drawing, there's my detail. It's already complete. So if I make changes to the model, if if I change a load, or if I put a different connection type on, all I do is re-detail that drawing and it's done. I can put it out in the shop. They use this information to build this beam. Is that pretty clear? Okay. In addition to putting this drawing in the shop, they also include a CNC file. So here we have a little icon of a little robot. Basically, you pick him, you select the beams that you want. I don't know where this one goes. And it generates information. That's just a single part. But this is X, Y, Z locations. This is a hole. At 101 inches from the left end, it's going to put a 3/4 inch hole. I don't know, 25 of them. I don't know what the math is. But basically, this file goes out to a robot. And that robot will start drilling the beams, the clip angles, the gusset plates, and all that. So that's why someone would use SDS2. It's a manufacturing solution. Drawings and CNC information. Has anybody ever been in a fabrication shop and seen these CNC machines before? No? They can weld, they can drill, they can cut. Now they even have them where they can assemble. So when the beam's coming down, it can grab a clip angle and set it on there and start welding it without anybody touching it. And we are automating that process with other software developers. So again, another opportunity where interoperability has to work. Okay. All right. How am I doing on time? Okay.
Good.
All right. I'm going to show you next, basically, what the steel erector would use the SDS2 model for. And again, it's another example of interoperability where this model is used for not only manufacturing the part, they created the drawings, the structural steel detailer created the drawings, they exported information to the CNC robots. Now we're going to go put some cranes in here to use this model on the job site to make sure that everything that we're building can be erected safely and lifted given the crane that they have. So here, I'm going to go to plan view. Okay. So it's the same structural steel model that we had in Revit. I'm going to add a crane. I'm going to select the type of crane. Pick a 70-footer. Okay. Alright, so this is a specific type of crane that the erector might have, or they're maybe making the decision of what crane will work in this situation. So I'm going to place the crane in the model, and if you see those rings, those are the different levels of lifting that can happen. It's maybe a little better viewable in 3D. I'll go to 3D first. So here I'm positioning the tracks. Okay. Now it's asking me, here's what's telling me what I need to do next. It's saying select the furthest laydown point. So where's my truck going to be driving by where I'm going to pick the stuff off the truck, or where's my laydown yard where all the steel is going to be sitting in a pile? Well, maybe my crane has to pick up from a point way over here. All right, now I'm going to orientate where my boom is going to be. I'll go over there. Now that part of it's just visual. So basically, I added a crane in this model that the erector is going to use. So a few tools that the erector might want to use is, given this crane and this location, what members can I put up? I pick this tool here, I locate the crane that I'm trying to analyze, and in 3D view, you can see, how it looks like a upside down, no, I guess it looks more like a wedding cake. As this boom changes angle, it can't lift as high, nor can it lift as much. Well, this ring, the difference between the top of this ring and the top of this ring is a chart inside of the crane saying, I can only lift 5,000 pounds at this height, but I can lift 6,000 pounds at this height, and so on. The closer it gets to the crane, the more it can lift. And that's all calculated in much the same way the design calculations you've seen for the connection. We have similar connection or calculations for the crane. What can it do at this location? Can it pick it up safely? And can I reach it? So if I right-click and say OK to this, the members that are in green pass the test, meaning I can erect them safely and I can reach them. So a new term that I'm going to throw out here is called site logistics. The erector is going to use this software to try to help plan the position of the crane, or maybe even determine what size crane they're going to be using on the job. As you can tell, if I just use the crane in this location, I can't erect the steel on this end. So that means two things. I'm going to need another crane, or I'm going to have to position the crane again. And one of the most expensive tasks on a job site is repositioning a crane. And a lot of people don't understand that, but it's really expensive. So they're going to try to select a position that the one crane can satisfy everything, or they're going to get a bigger crane, or they're going to have to plan in their schedule to reposition the crane. Because if that crane is waiting for steel, if steel's sitting there waiting on that crane, it's a lot of money, vice versa also. But basically, a lot of people don't understand that crane placement is very important to a project. I'm going to go back in and add another type of crane. Well, any questions on that so far? All right. Well, since we couldn't get all of the steel put up with that one crane, I'm going to add another type of crane. I'm going to put a tower crane in. This is a much larger crane, probably a little overkill for this project. You'll see. See how that, no matter, I can put my crane way out there and still reach it. Well, probably getting too big of a crane then, right? But the point is, this tool can help the erector decide what crane they could use or need to use. This is a tower crane, so there's a big concrete footing under it. We're going to position the footing so that it doesn't disturb any of the footings or walls of the current structure. Furthest laydown point, so my laydown yard where all the steel is going to be unloaded off the trucks maybe is at that location. And choose jib orientation. So maybe set it out here. Okay. So there's my tower crane. If one crane can't get it, we have it, the other one can now. So do you kind of see the importance of the software being interoperable, especially between the detailing model, the Revit model, and now the erector? All this information has to play together to work right. That's basically it inside of SDS2. Oh no, I do have one more. Let's do this. One more example of interoperability. I'm just going to leave it there. I'm going to start a file that's going to start importing here. So I'll start this and I'll talk. So notice this model doesn't have any steel joists on it over here. An example of local interoperability between two companies is between Design Data or Lincoln and Voltcraft in Norfolk. I've seen a few people had some ductwork up on their screen in Navisworks or in Revit. Well, ductwork is a design system, right? I mean, we all design the size, how long of a run, what size fan, and so on. Well, those systems have to go in the roof area of these ceilings? Well, if you looked at one of these ceiling tiles, you're going to see steel joists or steel beams in there. Well, you can't just cut holes in the beams to put a ductwork through it. It has to go through openings that already exist. And one of the member types that we're trying to get defined early are the joists. So Design Data worked closely with Volcraft, and you'll see these joists start to be placed in the model. The workflow is, you've seen how we built the model in Revit, we brought it into SDS2. Once it's in SDS2, I take a file from SDS2 and send it to Volcraft. That file contains the section sizes and the locations in the model. And most importantly, it has something called a GUID on it. As you guys get more technical, you'll hear this term. A GUID is super important to interoperability because I have to be able to identify this column in SDS2 and in Revit. So the only link between the two is an ID number. It's a license plate number. It's a serial plate. It's a serial number. This one has a very specific number to it. Well, I pass that very specific number off to Volcraft in Norfolk. They design a joist that's going to be sitting on top of this, and when they return it back to me, I know where to position the joist in the model because they sent that number to me and I said, position relative to this column, I'm 2 foot to the left, draw the joist here. So GUIDs are very important in the interoperability world. IFC files, if you guys do share them, look inside there, you'll see all kinds of GUIDs. IFC is readable to the human eye, so if you do a file find, you'll see those inside the file. Alright, the process is done. It takes a minute or two, but these are basically joists that were engineered from the Volcraft software in Norfolk. So that's, and the reason I wanted to show you that is, that's not a local level. Interoperability, working with software companies overseas or nationwide companies, yes, it's very important. But it's also important to pick up the people that are doing things on a local level. Nucor is probably not real local, but the Volcraft plant in Norfolk is. And they have the software that does it for all their other plants. So what they're doing here is basically designing it. Now I can take this into Navisworks and combine that with your HVAC model, and I can see if your web of your joist clashes with any of your ductwork. That's why it's important. And right now here in Omaha, I probably can't say the name of it, but we're working with them to make sure that their sprinkler design software, all the sprinkler heads, which I know they're in here, you see one there, one there. Well, that piping up in the ceiling is 3 or 4 inch round piping. And by design, you don't want a whole bunch of elbows in there. You want to get as straight runs as possible. So what they'd like to do is, after Volcraft has designed these joists, they want to take that model and add their piping level to it. So again, interoperability in BIM 101 right there. Lots of trades working together in the same model to make that model rich with information. Okay. Any questions on that stuff? Yes?
I don't know, your SDS2 has a kind of function to create like a reading schedule from there, or kind of for cranes or the basic structure?
On what kind of a schedule?
The lifting schedule?
Yes, it does.
Yeah.
It's, I honestly, if I go here, oh, I know where it is. Model, crane, manage lifts,
Yeah.
and we also have the actual calculation, which I think is some kind of report. I don't honestly know how to get to it, but yes, we do have we're working really close with 2 erectors to make sure that the positioning that we have, they have reports that they have to fill out themselves, and this will automatically fill those reports in. Yep.
Erection schedule, right?
Not so much time,
I
but,
mean, not time.
but
I'm talking
load
about
and reach.
Yeah, material
Yes.
by material.
Yes, exactly. That it does that. I don't honestly know how to do it. You can even break it up to where if you had a truss that's being erected and you have 2 crawler cranes, you can calculate the load on the 2 crawler cranes. That goes way deeper than what I know, but I know it has that capability.
Yeah, so Qubit was using your software to do that kind of thing, I believe. I think they demonstrated last year
Okay.
how to make a schedule, not time schedule, I mean the erection schedule for each material time.
And I believe they are just starting a project in the next month that will be using the SDS2 erector, and it's local. I'm not sure of the project, but I've seen a lot of things. We just had them in our office for training, so we know that's going forward. Yep, good question. All right. So that kind of ends SDS2 demonstration. I'm going to take this model and we're going to look at it in Navisworks. Obviously, you guys have had a lot of hands-on with Navisworks already, so I'll just kind of do the outside layer of that software. So here's that basic training model in SDS2. And I didn't do it with the joist yet, but basically you can see them there. Something that SDS2 also does to speed up the process of this joist design is Volcraft is working with us to put their standard panel joist design inside of SDS2. So instead of sending that file off and waiting a day or 2 to get the file back, we're building a plug-in with them so that it'll size that joist right inside of SDS2, but only the standard panel, like what the Steel Joist Institute might do. If it's got specific loading, that'll always have to be engineered. But I wanted to show you, this is basically taking a BIM model from Revit through, oh, I missed Libre though, Synchro.
Synchro.
Yeah, let's go to Synchro before I go to this. Okay, this software basically would pull an IFC file in from SDS2. So this structure would come from SDS2. The task list would come from SDS2 because inside of SDS2 I would have brought Microsoft Project Task List in and said these, inside of SDS2 I'd say these columns are sequence 1 columns. So I would go to my task list and say anything here that these columns are sequence 1 and then sequence 2 and so on. The reason why that's important is I need to bind a task on the Microsoft or on the project task list to a 3D element so that when a schedule gets applied to the task, you'll see that things turn on and off in the model. So this is basically introducing 4D into the BIM world. I don't know if you guys talked about 4D yet at all. Okay, so time is that 4D, right? Well, here's basically a good application of that. I have the SDS2 model. I have a task assigned to that model. This is not our software. This is another company's software, but it's demonstrating interoperability. And then basically, this tool lets them assign that task and that object to a schedule. So you'll see here, I will hit the play button, and this building has a schedule of like June to July being put up. So if I take this little bar, which is basically my viewer bar, and I back it up, see things that are disappearing, right? It's because sequence 1, sequence 2 basically is being worked on. I'll go the other way. So I'm going to start here. Here we have an empty slate. Start right here. Okay, here they're going to put up the fence. So if I look at school one. Oh, here it is. Okay, so excavation. See the red one? There they excavated. Here, you'll start seeing the foundations. As I get into that part of the schedule, the foundation starts to show up. And as I keep going, you'll see columns show up, so on. So this is your schedule bound to a task. If I have 2 days assigned to excavating, and I move my bar 2 days, the excavating task is finished, and then the next one's applied. So do you kind of see how the schedule is getting applied to time? I'm sorry, the task is getting applied to time. When you apply the task to a time, and the task is bound to a model, the result is, as I move this bar, you're going to see the 3D object appear and disappear depending on where I'm at on my schedule. It's a very powerful scheduling software. So I'm going to back it up here, and I'm just going to basically hit a play button and let it go. Okay, so each jump is, I think, 1 day. So there they excavated, the fence is up, they pour in the first floor, footings. It's usually the item in green you have to watch. I'll zoom in a little further. So there they poured the pad footings. Oh, there's the pads. There's the concrete. Now they moved in some cranes. Columns. So you see the red line jumping. And as that red line's jumping, it's just continuing to read where these tasks are. So at any point in time, the general contractor, who is most likely using the software, it really points out, well, wait a minute, I can't work in this area yet. Why? Well, because I have a crane there. I can't move the crane to have the electrical guy dig the trench. You know, it's that type of site logistics that happen. So those look like individual concrete pours. So here you see the animation, the bucket, meaning all the equipment has to go up 1 floor. And you know, that might take a day, might take an hour, but basically it's part of the animation. So now they took the tower crane down, they put a top on the atrium. And most likely, as this is going by, you'll most likely see work being done on the inside. Because there is an electrical portion of this model and the piping, so the concrete slab kind of covers it up, but there is more stuff going on in there. The glass is being installed, the parking lot, sidewalks, and curbs were poured, glazing put on top, and then finally your landscaping, trees, light poles, until it's finally done like that. So this software was neat to demonstrate in the interoperability world is we took a Microsoft project task list, bound it to a 3D element inside of SDS2. That way we know that what does level 1 slab mean? Well, we're only defining structural steel, so wherever the structural steel is, but basically we bind that element to this task list. The erector will come in and define the task to the schedule, and then you come back in and basically play the schedule, and they can stop at any given point in time. So here's Sunday, May 23rd, 2010. This is where the building should be. And if there's any deviations, you can take any of these tasks and push them out. And depending on what dependencies you have in their task list, it'll push the schedule out. And by doing that, they say, well, wait a minute, you can't push that task out because you've got contractors in this area on this date. So that's the type of software that this is very good at. Or that type of task this software is very good at. So that was a good demonstration, I think, on 4D. Any questions on that? All right. And then, kind of back to where we're kind of wrapping it up here, taking that and assembling all the disciplines together inside of Navisworks, you could see that the general contractor would most likely have that scheduling software in his job trailer. They're going to most likely have Navisworks with a variety of models to depending on where they're at in the construction phase. That basically finishes the demonstrations up. Any questions on that so far? Okay, we'll go back to this here. Smith, if you want to take the wheel, just in case that thing starts running away from you. So inside of Navisworks there, I think you guys have probably already covered this topic, but what are some of the big benefits? Clash detection is probably one of your most important ones first. Let's look at the obvious things. Do I have a column going where a beam should be and they can't coexist, right? So, or piping through a beam and so on. And the whole idea behind that is it is much cheaper to identify those types of collisions in a modeling environment rather than finding out that that collision happens in the real world and you got to shut down cranes and you got to send crews home until something's fixed, right? So it's much cheaper to determine that earlier. Facilities management. You guys get into that at all in this class, facilities management? Okay. So the concept here is when we're done putting all of this information into a model, that model's handed off to the owner. That owner is most likely going to use that for a facilities management point of view, meaning if they're going to add on 5 years down the road, wouldn't it be nice to have that model so that you could send it back to a software and add on? You'll know where the beam is, you'll know where the columns are, you'll know what size the concrete walls are, and so on. So there's a lot of value there. In addition to that, even on our small little building at Design Data, we have a computer in Tom's office that basically controls the air conditioner, the VAV boxes, the water circulating out in the pond for basically cooling because we have a lot of heat gain in our building because it's glass. And all of that information can be linked into the 3D model, even to the point where some facility managers use a model because there are life cycles on things. Let's say the handrails outside are galvanized, or not galvanized, maybe they're structural steel of some type. Well, we know that that's going to have a 7-year life cycle and then posts are going to rust out and have to be replaced. Well, they might use that level of information inside the model to say, hey, this has a life cycle of 7 years. So they're going to put this to a schedule, and they know then that these items within the building are going to have to be replaced at this year or at this month or quarter or so on. So there's a lot of the information in the model that can be used just to monitor the different systems within the building. Structural steel was our handrail, but a lot of people do that for HVAC, boilers, air conditioners, and things like that, so that the life cycle, the parts, things like that. So, and next slide, I think we're getting close to the end here. All right, so here's your quiz. Name 3 of the softwares besides Revit that we've seen today in our demonstrations that would add BIM value, add BIM information to the model. What's 3 of them that we used? All right, SDS2. I heard a lot of sides. It's Synchro. I'll give you that one. What's another one? What is it? RAM. All right, we did mention that. And RAM, in that case, and where we mentioned it was, is inside of Revit. RAM has a plug-in that brings values in from their engineering that we can use inside of Connection Design. So interoperability is super important because look how many software we talked about today. Next slide. Keep going. There we go. I mean, we've mentioned a lot of these, but really in the perfect world, it'd be all these softwares communicate with each other. And a lot of people say, well, why can't one software do it all? I don't know. Look at Revit. And you guys scratched the surface probably on architecture, and as you get deeper into it, you're in a design phase. You're not even at a manufacturing level yet. And manufacturing is a whole nother layer of information that Revit is just not going to be able to do anytime in the near future. That's why other modeling softwares like Design Data is out there to take that design and continue to the manufacturing level. So, a couple more here, I think. So where is it headed in the future? A couple of things. First of all is cloud computing. Do you guys use BIM 360 here? Autodesk BIM 360? So if you're doing a rendering of your model, now you guys probably know what a rendering is, right? Inside of Revit. It takes a long time to do that. Cloud computing allows you to take a file, send it to, I don't know if I'm going to get this right, send it to a supercomputer on the internet somewhere, and it computes it and sends you the result back. That's cloud computing. And Autodesk is really doing a good job with their BIM 360 software to do this. Here's why that's important. If you have an architect engineering company and your architect's in Omaha and your engineering group's in Denver, and you're working on the same project, you can synchronize the model and do a lot of these processes much quicker with cloud computing. It also, the BIM 360 allows people to put things at a common location. I've seen a lot of people use Dropbox in here. Well, it's the same theory. It's one place that you can go to several. You can go to home and access everything you need, or Google Drive is a similar thing. You put it in a location, it's accessible anywhere you have a internet browser. This is the same thing except at a much higher level. Cloud computing is the horsepower, and the BIM 360 is the storing place of all of this information for the various disciplines that use the Autodesk software. That's kind of where it's headed. So internet-based, mobile devices. SDS2 has a mobile line of software. So here comes I'm at a job site, here comes a semi-truck down the road and has a whole bunch of steel on it. Well, there's little bitty barcodes, stickers on the side of that beam where I can take out my average cell phone, scan the barcodes, and I know exactly what came in that gate, because the information that I scanned on my phone gets sent to the SDS2 computer and basically says, this beam arrived today, this beam arrived today, this beam arrived today. So now the erector knows, oh, I can put those up. So mobile devices are playing a big role with a lot of the 3D models today by updating information that's happening at the job site or a fabrication site or whatever, or a fabrication shop. So that's kind of where it's headed. Next slide. Well, we already did that. This is our software that Design Data sells. Engineering basically kind of does what RAM does, not quite as powerful, but a similar concept there. Lots of different things that you kind of seen today, but tailored specifically for a particular trade. Mobile, and Design Data is a distributor of that Synchro software that you guys see today too. So I put this slide up here because basically right now all of these softwares are interoperable because it's using the same model. And if any platform designs around that, you've got really good hooks in and out of other softwares, like Revit and so on. Next one. Oh yeah, we already did your quiz. So, by the time I put this together, Smith wasn't on board yet, but Michael Smith joined us. But if you got any questions, contact myself or Tom. Got a couple of websites up there. If somebody wants a business card, I'll give them a business card too. I will make a mention of the fact that Design Data donates SDS2 and SDS2 Connect to schools. We have basically only a small criteria that schools have to meet. One, the software has to be used in an educational environment, just kind of similar to what you've seen today. And two, we'd like to see their curriculum, how it's applied. But outside that, it's just basically donated at no cost to the school as long as they're actively using it and are applying it for educational purposes. So I don't know if that's entertaining. It's probably not from a student. That's more of a note off to others that if it's something you guys, if it's something you've seen today in SDS2, we can get you that software and try to help write a curriculum with you if that fits the design of this course. So, and we've got some other sample curriculums out there of how it was implemented in the past, so it doesn't, it's not like you have to start out from scratch. So
It's in some 40 schools, so.
yeah, as I say, we have a lot of
technical
schools using it.
Universities.
And we did that quite a while ago, and it's pretty popular in a way that lots of other software companies charge for the software to be on that. I mean, your tuition, some of that money is going to the softwares that are here on these machines. And you know, if it's a value to the program, you can certainly use the software. No problem. And on that note, that's all I had, unless somebody's got some final questions for me. All right, are you guys smarter? All right, good. Thank you.